Myself, Dr. Prashant Kumar Vartun, Professor, Department of Mechanical Engineering, GIS College of Engineering. My subject topics: Advanced Welding Technology, ME 703A. Course objective: after completion of this course, all students will meet the following objectives: to impart knowledge on various advanced welding processes so that the student can apply them in engineering industry applications. To develop the knowledge on the design of welded joints and the quality control of weldments. Course outcome: upon completion of this course, student will be able to achieve deeper knowledge of welding materials, technology of welding processes, deeper knowledge of different metals and their properties in welded construction, knowledge of quality technique at production by welding, knowledge of current computer robotic system and cost for the welding operations. Advanced Welding Technology, ME 703A. There are several modules. Module 1, Introduction and Review of Welding Process and Joint Design. Module 2, Process of Fusion Welding, Arc Welding, Submerged Arc Welding, Sealed Metal Arc Welding, Gas Metal Arc Welding. Module 3, Solid State Welding Process, Pressure Welding. Module 4, Friction Welding, Electron beam welding, ultrasonic welding, plasma arc welding. Module 5, gas tungsten arc welding, plasma arc welding, arc welding equipments, electrode selections. Module 6, welding metallurgy has weldability of plain carbon steels, stainless steels, cast iron, aluminum. Module 7, welding defects, types, causes, inspection, remedial measures, testing of welded joints by visual, vibration test, radiography, ultrasonography test, safe practices in welding. Prerequisites: manufacturing technology, welding technology, and joining of metals. COPO mapping of the subject. This is 12 POs, 4 COs against this 12 POs. These are the average figure. It is showing, this average figure is showing. So we can find out the how the effect of the society, total 12 points, 12 POs. Advanced Welding Technology, ME 703A. Today selection number 5, Submerged Arc Welding by myself, Dr. Prashant Kumar Vartun, Professor of the Department of Mechanical Engineering, GIS College of Engineering, Kollam. Outline: this introduction to submerged arc welding, processes, features, general operating conditions, types of submerged arc welding. Outline: advantages, limitations, applications. Introduction to submerged arc welding. Submerged arc welding is a method in which heat required to fuse the metal is generated by an arc formed by an electric current passing between the electrode and the workpieces. There is no visible arc and no spark, spatter, or fumes. This electrode may be a solid or cold wire or stream. Submerged arc welding is normally a mechanized process. This is a submerged arc welding. Two pictures are there. The submerged arc welding process is there. This is a arcing process, arcing is done, and this fluxes are coming from this, and it is covered in the arc. So fluxes are fused, and under this welding joints are being produced. So from this point, it is coming to this. So arc welding, submerged arc welding is basically when thick plate is required to weld submerged arc welding is preferred because it can productivity is much higher than other processes. Here is also submerged. This is a fluxes coming. Is from this point is arcing and fluxes are covered. So this is doing the two different machines are there. So it is a picture of the submerged arc welding process. Similar to MIG welding, submerged arc welding involves formation of arc between a continuously fed bare wire electrode and the workpiece. The process uses a flux to generate protective gases and slag and to add alloying elements to the weld board. A sealing gas is not required. Prior to welding, a thin layer of flux powder is placed on the workpiece surface. Process of submerged arc welding, the arc moves along the joint line, and as it does, as it so, excess flux is recycled via a hopper. Remaining fluxes slag layers can be easily removed after welding. As the arc is completely covered by the flux layer, heat loss is extremely low. This produces a thermal efficiency as high as 60% compared with 25% for manual metal arc. There is no visible arc light, welding is spatter free, and there is no need for fume extraction. Process of submerged arc welding. The molten weld and the arc zone are protected from the atmospheric contamination by being submerged under a blanket of granular flexible flux. Flux consists of lime, silica, manganese oxides, calcium, fluoride, and other compounds. When molten, the flux becomes conductive and produces a current path between the electrode and the valve. This thick layer of flux completely covered the molten metal, thus preventing spatter and spark, as well as suppressing the intense ultraviolet radiation and fumes that are a part of the shielded metal arc welding, submerged arc welding process. Shielded metal arc process. Process of submerged arc welding. Submerged arc welding is a common arc welding process that involves the formation of an arc between a continuously fed electrode and the workpiece. A blanket of powder flux generates a protective gas shield and a slag, and may also be used to add alloying elements to weld pool, which protects the weld zone. Process of submerged arc welding. This is the contact tips. That is, this is the tips. This is fluxes are coming, and the arc is formed. This is another electrode wire. This is electrode wire, and this is from the hopper. Fluxes are coming. So this is already welded, right? And these directions, residual fluxes, slag layer, weld deposit, arc thread, flux layer. This is flux layer. This is direction of welding. Flux fed from the hopper, flux fed to the joint, AC or DC supply play. Fluxes used in submerged arc welding are granular, fusible minerals containing oxides of manganese, silicon, titanium, aluminum, calcium, zirconium, magnesium, and other compounds such as calcium fluoride is specially formulated to be compatible with a given electrode wire type, so that the combination of flux and wire yields desired mechanical properties. Types of fluxes. The main two types of fluxes were submerged arc welding, bonded fluxes produced by drying the ingredients and bonding them with a low melting point compound such as sodium silicate. Most bonded fluxes containing metallic deoxidizer which helps to prevent the weld porosity. These fluxes are effectively over rust and mill scale. Fluxes, fused flux produced by mixing the ingredients, then melting them in an electric furnace to form a chemically homogeneous product, cooled and ground to the required particle size, smooth, stable arc with welding currents up to 2000 ampere, and consistent weld metal properties are essential of these fluxes. Features of submerged arc welding: flux hopper. It stored the flux and control the rate of flux deposition on the welding joint. Welding head, it feeds flux and filler metal to the welding joints. Electrode, filler metal gets energized here. Flux, the granulated flux seals and thus protects molten weld from atmospheric contamination. The flux cleans weld metal and can modify its chemical compositions. Features of submerged arc welding: electrode. Submerged arc welding filler material usually is a standard wear as well as other special form. This wear normally has a thickness of 1.6 millimeter to 6 millimeter. That is 1 by 16 inch to 1/4 inch. In certain circumstances, twisted wear can be used to give the arc an oscillating movement. This helps fuse the toe of weld to the base metal. The electrode composition depends upon the material being welded. Alloy elements may be added in the electrode. Electrodes are available in weld mild steels, high carbon steels, low and special alloy steels, stainless steels, some of the non-ferrous of copper and nickel alloys. General operating conditions: current, the total welding current can range between the 100 to 3600 amperes, where in one molten pool, that is from 1 to 6, voltage is 20 to 50 degree volt, speed is 30 to 350 centimeter per minute, deposition rate is 2 to 100 kg per hour. So deposition rate is 2, very high, 2 to 100 kg per hour, so very high productive machine. Types of saw: submerged arc welding can be divided into 5 types: single wear, twin wear, tandem twin, multi wear. This is I'll show you from one single wear. Single wear welding is the most widely used submerged arc welding method. DC power source is used. This is a single flux, and this is the wire is coming, and this is the power sources, and this is filling area, flux filled. This is base metal. Welding reactions and welding wire reel. This is wire reel and wire feed unit. This is wire feed unit. So the solid and cold wire of diameter 2.0 to 4 millimeter are used. A small diameter produce a higher deposition rate at the submerged arc welding rate. At the same rate, twin wire, for twin wire welding, 2 wires are connected to the same power source. DC power source is used. It offers up to 30% higher deposition rate and can be used at higher current and speeds. Very high welding speed can be achieved in fillet welding. Welding wires, flux. The 2 wires are coming. Wire feed. This is flux fill, welding directions, hopper, flux hopper, this power source. This is a twin wire machine, same power source. two wires are connected to the same power source. Next, tandem. In tandem subarc welding, each of the two wires is connected to its own power source and is fed simultaneously by its own wire feed unit. Both AC and DC source can be used. The wires are normally large diameter, 3.0 to 5 millimeter, and deposition rate are about twice that of single wire. So two wires are this. This is one reel, and this is one reel. The two wires are coming, and the hopper is common. So fluxes are being done. Two wires are, the welding is performed simultaneously. So deposition rate is higher, much twice that of single wire welding. Tandem with twin. So this sub-tandem twin process involves two twin wire heads placed in sequence. This is a twin wire and another is a twin wire. So both AC and DC source can be used with the use of 4 into 2.5 millimeter diameter, where deposition rate up to up to 38 kg per hour can be achieved. So higher to give higher productivity, this machine can be used. This tandem twin process involves two twin wires heads placed in the sequence. So this is two wires, another is two wires. So in this direction, flux hopper is single, so it can weld 4 times than of single wire, 4 times that of single wire. So 38 kg per hour can be achieved, deposition rate. This is 38 per kg can be achieved. Initially, I told that submerged arc welding is basically designed for it is automatic welding can be done, and also for thicker plate, which is used for thicker joints for thicker plate welding. It is used. So 38 kg per hour is a high productive machine. It is so it can be used for thick plate welding with higher productivity. Multi-wire. This is multi-wire. Up to 6 wires can be used together, each with their own power source. The lead wire is usually DC plus polarity, with the trailing wires being AC. The speed of up to 2.5 meter per minute can be achieved, giving a maximum deposition rate of 90 kg per hour. This technique is particularly suitable for longitudinal pipe welding. This is a 6 wire can be used together. This is flexible. This is three-wheeler wheel. This is power source. This is power source. Both sides it is power source is given. One is DC and other trailing wires are AC. So multi-wire submerged arc welding machine. Advantage of submerged arc welding. One of the top advantages of submerged arc welding is to prevent hot material from splattering and splashing on the workers. Another benefit is that the flux prevents high level of radiation from the being emitted into the air. Submerged arc welding does not require added pressure to weld because it is already generated by the electrode. This application is excellent for quickly welding together thin metal sheets and create a secure fusion between the welds. This application also produces high productivity, fast travel, speed, high repeatability, and quality results. Advantage of submerged arc welding: strong, sound welds are readily made. High quality, little risk of undercut and porosity. No spatter, very little risk of lack of fusion due to deep and safe penetration. High diffusion rate, minimal edge preparation. Advantage of submerged charcoal: minimum welding fumes are emitted, high thermal efficiency, no radiation, high welding speed are possible, deep penetration, low distortion. Submerged charcoal is suitable for both indoor and outdoor work. Disadvantages of submerged charcoal welding: most like most applications, there are some limitations to submerged charcoal welding. One is that material that can be welded by submerged charcoal is limited to steel, stainless steel, and some nickel. Submerged arc welding is also limited to materials that are long and straight or are rotated pipes. And despite having some safety advantages, there is still the risk of having the residue from the flux left behind, which could be harmful to employee health. Limitations of submerged arc welding: precise joint preparation required, no observation of arc and process during welding is possible, high operation effort, it cannot be used for plates less than 5 millimeter thickness. Limitations of submerged arc welding: flux is subject to contamination and absorption of moisture, solidification cracking, irregular wear feed. These are the limitations. Application: submerged arc is ideally suited for longitudinal and circumferential butt joints. Due to high fluidity of the weld pool, molten slag and lack of layers, molten slag welding is generally carried out on butt joints in flat positions, and fillet joints are in both flat and horizontal vertical positions. Fabrication of boiler pressure vessels, railroad link tank cards, structural shapes and cylinders, circular welds, beam production. These are the application of submerged arc welding. Application of submerged arc welding is shipbuilding, circumferential welding in wind tower, wind tower fabrication, longitudinal pipe welding, nickel-based alloy, surface applications. Implementing submerged arc welding applications. When implementing a submerged arc welding application, it is important to touch a robot with at least 25 kg capacity. This is important because submerged robot can be applied in submerged arc welding. This will allow the robot to be able to hold the wear feed and flux. Units such as the Fanuc arc mate 120 IC and the Fanuc arc mate 120 IB would be good choice for a submerged arc welding application. It is also important to have a large power supply, one that is at least capable of pulling 1000 amperes of weld current. So implementation of the submerged arc welding by robots gives high productive and good result on welding and also uh, higher productivity. This is some questions MCQ. Submerged arc welding is a process which uses a mixture of iron oxide, granular aluminum, be accomplished by maintaining a hot molten metal pool between plates. C. A process in which arc is maintained under a blanket of flux. D. All of the above. The submerged arc welding. So these are the four processes are given. To which one is correct, we have to will discuss, and then correct answer will be given. Fluxes uses mixture of iron oxide and granules. It cannot be flux. Accomplished by maintaining hot molten pool between plates. It's not that. Fluxes. This is we are talking about submerged welding is a process in which arc is maintained under a blanket of flux. This is probably the correct answer. A process in which arc is maintained under a blanket of flux. And D is all of the above. So C is the correct answer. So it is a process maintained under a blanket of flux that we have already shown in the picture. We have also discussed the matter. The arc welding transformer is a step up transformer, step down transformer, 1-to-1, or increased voltage. So in this case, arc welding transformer is basically because always we have seen the 25 to 30 or 35 voltage is required. So it should be step down, cannot be step up. 1-to-1 is not, increasing voltage is not. So B is the correct answer. Welding is a step down transformer. In which position is submerged arc welding is done? Flat and horizontal, flat and vertical, flat and overhead, horizontal and vertical. So submerged arc welding, as you have shown in the picture, flat and horizontal is A is the correct answer for submerged arc welding, flat and horizontal. Question number 4. What is the purpose of copper coating on the mild steel filler wire? Submerged arc welding and also MIG welding, MIG wire, submerged arc wire and MIG wire, there is a coating, copper coating is given. This answer is why it is given. Purpose, what is the purpose? To heat transfer, heat faster. B is to increase strength. C is to avoid rusting. D is for good appearance. It is not heat transfer, heat faster, not increase strength, to avoid rusting. To avoid rusting the steel, mild steel, filler wire, copper coating is given. No good appearance. Engineering appearance is secondary, but good is a good rust. To prevent the rusting on the wire, copper coating is given. So this is the submerged arc welding process is done. So thank you. This is a reference. Electric welding, published in 1935. This is a Lloyd, James Jones, Lloyd's, and Harry Edward Kennedy, and Arthur Rothermund. They have published the electric welding, and China's Larry welding, principle and application of applications, Kolinsky, Thomson, Delmar Learning, 2002. This Kalpakjan, Skorab, and Stephen is manufacturing, engineering, and technology, 5th edition, upper saddle. Is Pearson's Antisol, 2006, and Manisevar calculator from Weld Engineering Company, Incorporated, assessed June 18, 2009, and also from Science Direct. So many papers are there where we have collected the things. Thank you very much for your patience, in this lecture. Thank you.